Namaskar, welcome back. Now, this is one of the important topic apart from the magnitudes and the seismic waves and all that. This topic will talk about the lab and field observations and methods which are followed to identify active faults, how we are going to map it. Of course, it will have more lectures on the mapping techniques and all that, but in this we will briefly cover everything, okay, right from the lab to your final observations, where we will be using different techniques, okay, like airborne instruments, satellite data, okay, geophysical methods we will use here, and of course we will go in field and then try to map the landforms. Okay. Now, remnants of paleo earthquakes, because the most important part for us is to identify the signatures or the left out information or the imprints of the paleo earthquakes, ancient earthquakes. So, how we are going to do that? One is we will try to identify the landforms which are formed or developed by the earthquakes or during earthquakes, and then we will also see the information which is preserved in near subsurface sedimentary succession. So, we can classify this as an primary and secondary evidence, as we have done in primary structures and secondary structures. Okay. So, some evidence which are primary we classify, those are the evidence or the signatures which are formed by the earthquake on fault and due to the displacement on fault. And the secondary are, they can be associated with ground shaking, which are also important. So, primary evidence are those produced by tectonic deformation during co-seismic slip, okay. Co-seismic at the time of the earthquake. Okay. So, any earthquake, if it is a surface rupturing earthquake, will result into the displacement of along the fault plane. So, either it will go up, that classification will come when we are talking about the fault in particular, or the blocks can go down, or it will pass by each other. Okay. So, in short, the area will be uplifted, or the area will be down faulted, or it will have lateral movement. And this is at the time of the earthquake, that what we call the co-seismic. So, what type of landforms you are expecting because of this tectonic deformation? So, those are primary evidence, and we are mostly interested in identifying the primary evidence. That is what we call on fault. So, on fault, what type of landforms you will see? So, in short, you will see scarps. Okay. So, for example, if you have and first stage, you have, for example, you have this all horizontally deposited sediments. Okay. And we have a fault over here, okay, for example, and let us say this is the surface trace of that fault. So, this one is your fault line or trace, we can say. Then this one is your fault plane. Now, if suppose we have the sense of movement where this block is moving up, okay, and that is usually happens during the reverse faulting. So, in the next stage, when there is a displacement, then how you will see this. Okay. So, this one you have the fault which has moved up. Okay. And finally, what you see is the deformation section. Okay. So, this portion on the surface so earlier it was like this. Okay, you have the surface and then you have deformation. Okay. So, this block has gone up and the feature or the landform which has been developed is termed as scarp. So, you will come across scarps and that what we call fault scarps. Okay. And since they have occurred during the recent time, then we term this as an active fault scarps. Okay. So, such landforms are preserved on surface. You can also see the folds, okay, on a smaller scale or a very large scale. Okay. And that what we see is the folded mountain chain, that is your Himalayas. Okay. So, Himalaya is in folded mountain chain. Then when you come to the section, that is your sedimentary succession, and this you will see in section. Okay. And this is your plan view. So, there you will see colluvium, wedges, okay, folded stratas. So, for this you need to have sections. Okay. So, without section you will not be able to observe this information on fault of paleo earthquakes. So, you need to see the section like this. Okay. So, as I discussed in one of the lectures, that usually what we do after identifying the fault scarps, we open up the trenches over here. Okay. And then we go deeper and try to see what is preserved in the section. Okay. So, this we term this as an paleoseismic trenches. Further, off fault, again we are still talking about the primary and during the co-seismic slip, the deformation during the co-seismic slip. What you are going to see is off fault, that is away from the fault, we will see tilted surfaces, and mainly we can see the fluvial terraces which are getting tilted, or you have the alluvial fan surfaces. So, we will have a separate lecture on the landforms also, but try to just keep this in mind, that what we are talking about the surface, the land surface. Okay. So, they will be tilted, uplifted or round shorelines in the coastal areas. Even the uplifted terraces can be seen when you are close to the coastal regions, okay, where you have mega thrust earthquakes. along the subduction zones. Okay. So, along the rivers also we will see if the river is crossing. For example, in this case only, if you see this, okay, then if you have a river which is flowing through this, then you will see terraces which are formed in this area, because there is an uplift which has occurred here, and that will result into your formation of terraces. Again, unconformities, as we have discussed in the primary and the secondary structures, that the unconformities here could be because of the tectonic movement and then next phase of deposition or erosion. Okay. Tsunamis to some extent are off fault, but they are associated with the co-seismic movement. Okay. We will learn about the tsunamis and how the tsunamis are being generated and what are their effects. We will also talk in this course. Okay. Now, coming to the secondary structures or the secondary evidence. Okay. What all we will see, let us have a look. Okay. And mostly what we have experienced, and the reports are that the secondary structures, or this not secondary structures but secondary evidence, okay, are mostly seen off fault. But as per the definition, if we take, this is related to the strong ground shaking, okay, and that is what we call seismic shaking during a particular earthquake. It will also be seen, because it is related to seismic shaking, it will be observed on fault as well as off fault. Okay. And this is mainly what we call is the liquefaction. Okay. And this will be seen if you are having the unconsolidated sediments. Plus it should be water saturated. So, this will be an ideal condition for having this lateral spreads and all that. Okay. So, we will learn about the liquefaction in one of the coming lectures. Okay. At the same time, if you are having the loose material and a slope is present, then you will come across the landslides. Okay. And even with a very gentle slope, you will come across lateral spreads. And this part I have discussed very in the beginning, when we were looking at some evidence of the lateral spread in which was produced by 2001 Bhuj earthquake. Off fault, again the soft sediment deformation, what we call the seismites, okay, is again related to this with the water saturated deposits. And if you are having sediments which are covered or which are sitting in deep waters, then you will have turbidites. Okay. And in some time you will see that there is a rapid deposition or sedimentation is taking place. Okay. And transportation of the huge boulders, this is mostly during the time of a tsunami. So, such evidence will be seen off fault, away from the fault. So, as I told that this portion, that is your soft sediment deformation, is also related to your sand dikes and all that are related to your process of liquefaction only. Okay. But in pure sense, if you want to have a liquefaction, then you will see either the sand or the cohesive less sediments will be poured out on the surface. Okay. So, it will be like an volcanic eruptions which you see along in the subduction zone areas. Okay. So, the material will be poured out on the surface. Okay. Now, these are some hierarchical classification of paleoseismic evidence with examples of features. Okay. Now, this table I will briefly go about it, partly I have already discussed, and you can refer when you get these slides and all that. But we will have some discussion on this. Okay. Again, there is the part which we are talking about here is your primary evidence and the secondary evidence. So, primary evidence on fault and off fault. Similarly, secondary on fault and off fault. So, few most important features or the signatures you will come across were been discussed in the previous slide. So, as I mentioned and emphasized that one thing is that what we try to see is the location, because on fault and off fault is the location. For example, you have an fault here. Okay. So, this will be whatever the evidence you see close to this region, okay, close to this region will be your on fault, and if you are away from that, then we term this as an off fault. So, one is the important part is the location. Okay. Then second is your timing, that is what we were talking about, the co-seismic, instantaneous at the time of the earthquake. Delayed response, as we can see a sort of what is the pattern of erosion which was triggered by this earthquake, or there was a sort of an post relaxation, because as we learn about the elastic rebound theory, okay, we can also see a sort of an post relaxation. So, some adjustment will be there if you are having a large displacements, and also it can also result into the erosion and deposition in the area, on fault as well as off fault. So, if you look at here, we can just quickly look at see that what else is other than the timing, location. We will see the geomorphic expressions. Okay. So, this we are looking at on surface, and stratigraphic expression in section. So, evidence of this paleo earthquakes will be preserved as a geomorphic expression as well as in the stratigraphic expression. Okay. So, what you can see is that you will see a fault scarp, fissures, folds, small tracks, pressure ridges, okay, depending on what type of faulting is there. Okay. So, we will learn about this also, pressure ridges and all that, because this pressure ridges mostly is been seen when you are having a strike slip motion or movement. Okay. Then delayed response will be after slip contribution to future features as at left. Okay. And that is here this one, okay, contribution to this features. Okay. Colluvial apparent will be there. So, there will be an erosion and deposition triggered because of this tectonic activity. Off fault, again we are talking about instantaneous. We will see the tilting in the terraces or uplift in the terraces, subsidence of the shorelines or uplift of the shorelines and all that. Okay. But shorelines we will not see in Himalayas, we will see definitely along the coastal zones. Okay. Then delayed response, what we call is after. So, after it spends like it have longer time span after the earthquake. Okay. So, tectonic alluvial terraces, because erosion will occur if there is a change in the base level. For example, you have the slope. Okay. Now, this portion has gone up. So, river will try to cut here, okay, and that will result into the formation of alluvial terraces, and this will be after. So, this is a delayed response. You are having post seismic, okay, off fault, away from the fault. So, you may come across multiple terraces, more than the terraces which were been formed, because it is an erosional landform, and we also classify it as a depositional landforms. Okay. And there is a process of formation of terraces without tectonic movement also. Okay. which is related to the climatic fluctuations. So, but close to the fault or because of the deformation, you may have more number of terraces as in that area as compared to what you see on a regional scale in that particular drainage basin. Further stratigraphic expressions what you will have, because we are now talking about the sediment successions. Okay. So, the layers or the sedimentary units will be faulted. So, you will observe a sort of a displacement, it will also get folded, you will have discontinuities or disconformities in that region. Okay. Then you will also have if you have, because if there is an sort of an, so this was a surface and then now the surface has been deformed like this. Okay. So, there will be an erosion here. So, this part we will discuss when we are talking about in detail about that. Okay. So, what is the process of erosion of the scarp and all that. Okay. So, you may, so initially for example, you may have a scarp like this. Okay. But later because of the erosion you will see something like this. Okay. So, this part will get eroded. So, erosion and deposition of the scarp, formation of colluvial wedges. So, this part will be your colluvial wedge. So, this will be delayed response. Okay. Similarly, if you are having you are in the coastal areas, then you will come across there is a tsunami deposits. Okay. And certain erosion relate and that marks the unconformity in the environment. Okay. So, if you are, for example, you are having a very calm environment close to the coast, but suddenly you see a very coarse deposits which are coming and sitting on top of it, those that can indicate easily that there was an high energy event. Okay. Either it was storm or related to your tsunamis. Okay. Then further erosion, erosional unconformities will be developed or deposits and deposit induced by uplift and subsidence. Okay. Similarly, further like you have the secondary one. Okay. So, if you look at this one again on fault instantaneous geomorphic expressions, what you will see is the sand blows, as mostly at what we are talking about is the liquefaction. Okay. Then landslides, lateral spreads in faulted zones, disturbed trees and tree thrown craters. Okay. So, these are few examples. Delayed response, retrogression landslides originating in the fault zones. Okay. So, it may result into the landslides, and further off fault again you will have landslides and all that. Okay. And delayed response you will see similar retrogressive landslides beyond the fault zone. So, now this was the geomorphic expression. Okay. So, this part we have already discussed. So, I will just move ahead. So, just go through when you get the slides, at least it will help you in understanding this. Okay, part. Now, coming to the stratigraphic expression, you have the sand dikes and all that also we discussed about that. Okay. So, we will stop here and we will continue with more details on the lab techniques and the field techniques in the next lecture. Thank you so much. Namaskar.